Hey everyone, hello again, and welcome to the RAG using the Semantic Kernel with Azure OpenAI and Azure Cosmos DB for MongoDB vCore. It's a long name, and you will know why we are using this specific type of Azure Cosmos DB later in the presentation today. So I am John Aziz. I'm a Microsoft AI MVP, and I'm currently working as a coding instructor at a local company. I'm from Egypt, by the way. What are we going to get to today? We are going to learn about the Microsoft technologies used, and we are going to learn about the concepts behind them, and we're going to get a demo, a light demo for RAG in Jupyter notebooks. If you have any questions while I'm speaking, we are live, I'm live with you. Please let me know how to help you, to assist you. If something I'm saying is not clear, I will be reviewing the comments while I'm speaking, and I will make sure to get to your comment. So these are the prerequisites if you want to follow along with me today. You need a GitHub account, you need an Azure subscription. You can get here and activate your free Azure subscription right now. And if you are a student, you will have another benefit of Azure for students, which is a free subscription. It's another type for free subscriptions. And you need to apply for Azure OpenAI Access. If you have not already applied for Azure OpenAI Access, you won't be able to complete the demo today with me. So if you do have Azure OpenAI Access, I really encourage you to try and follow along. So what are the Microsoft technologies we are going to use today? The first one is code spaces. And code spaces will provide us with a playground where we can test stuff out without having to install anything locally. And let me send you the URL. Yeah, it will take several days. That's why I said that you will need to use Azure OpenAI. Okay, so I can't send you the URL. Can someone send the URL? Okay. This is the URL for the repo, which we will be working inside today. So this is the repo, and it's called RAG, the same name as the demo or the session. And it has some code which you don't have to worry about. And all we need to care about is that there is a button on the repos page that says open in code spaces. So just click on this button and leave it to load. It's not going to take much time. Oh, we need to click on create again. It's not going to take much time to load, but we are going to leave it and continue. Okay, so what else are we going to use? We're going to use Azure OpenAI, which is the way we are going to be able to make chat. And I think all of you have already heard about Azure OpenAI and ChatGPT and all of that. So you can chat with someone and do natural language. And that's why we are going to use Azure OpenAI for two main reasons. The first one is that we are able to have chat with our data. And the second reason is that we are going to make our data transformed into numbers, which is embeddings. And we will learn about this later. So we need two types of deployments. We need a chat deployment and embedding deployment. And let's do that. So we're going to go to Microsoft Azure, click on Azure OpenAI, and click on create. And then the steps are really easy, and we are only going to be creating two resources today. So just give it a name, for example, MongoDB, vCore, demo, RV. I have another one already created, but as a backup, but let's try to do it live. So how about we choose East US2 and then just give it a name, OpenAI workspace, VS Code, anything will work. Oh, yeah. And then let's choose standard S0, next, and then create. That's it. So you don't have to do a lot to be able to use Azure OpenAI. And that's us creating a service, and this service will allow us to use the models that I talked to you about before, the chat model and the text embedding model. While the model is being created, we are going to also create an Azure Cosmos DB for MongoDB vCore. And what is Azure Cosmos DB for MongoDB vCore? It's a type of database where I can store JSON documents. And there is a specific structure for it, which I need you to understand, because that's how we will build stuff. So we have our database account or database cluster. Inside this cluster, we can create lots of different databases. And inside each database, we can create a container. And this container will contain some JSON documents. So the container is the last thing. Think of it as a table in Excel, which contains all of our data. And Azure Cosmos DB for MongoDB vCore allows us to create the database and then use it from Python, from Node, from Java, from Ruby, with a connector from the language, like by Mongo. And if you want to learn more about it, you can hit this URL. But let's get back here and create our chat and embedding deployments. So I'm just going to click on go to Azure OpenAI Studio. And we are going to click on the first button that appears on the screen, which is create deployment, surprisingly. And then let's wait, it's loading. And yay, the create deployment here. Now let's click on it, create a new deployment, select GPT-3.5 Turbo, which is ChatGPT model, and let's name it chat deployment. And then click on create. And we are going to create another deployment, which is called the embedding deployment. And you can use text embedding, any one of those, but we're going to use EDA. And let's name it embedding deployment. Okay, now click on create. That's step one. We are done with Azure OpenAI. Now we go back to the portal to create the Azure Cosmos DB from MongoDB vCore. And we are not using Azure Cosmos DB because it can elastically scale up to lots of storage, or it has lots of cool features. It's super fast, read and write, everything is cool about it. But we are using it for one reason, which we will get back to the slides and know. So let's just create it and name it anything. VS Code Live and which one is it? I can't remember. I guess this one. It's not going to make a difference. And let's choose the same region that we chose before. Click on configure, and we are going to choose the smallest one. And by the way, you can use it for free. But we are going to choose the M25 tier. And this is how many CPUs or virtual cores that are being provisioned when we create this resource. And the storage, we are going to choose the smallest storage option, which is a 32 gigabyte. And click on save, and that's it. Click on review and create. Okay, wait for it to check everything. And then, hello. Oh, I didn't do something. What didn't? Oh, I did not add an admin. I did not add my database credentials. So you need to add the Cosmos DB admin and the password. I'm gonna use a password that I know very good, and then click on create. Oh, I forgot the firewall rules too. Oh God, well, I keep forgetting stuff. So by the way, this is a really important step in the networking, because if I did not add my current IP address to the firewall rules, I won't be able to access this database, and it's gonna give you a timeout error when you try to use it in Python. So just click here, click allow public access to from Azure services. This is not public access for everyone. And then review and create, and click on create. That's great, Phoenix. And then let's get back to the slides and continue. So why Cosmos DB for MongoDB vCore? So it has a very cool feature which is built-in vector search. And what that means is that I don't have to perform my search somewhere and store my data somewhere else. I can store my data, which is a bunch of numbers, the embeddings, and perform search over them at the same place. And that's very good because I don't have to care about the other resources. Are they working? And it makes the complexity of my solution look way much lower. Because we only have to care about two resources right now, Azure Cosmos DB for MongoDB vCore and Azure OpenAI. And because we want to get started easily, we will be using the semantic kernel. And the semantic kernel will orchestrate all of these things together. It will communicate with the database, it will communicate with Azure OpenAI, and do the RAG for us. So we won't be doing much. We will be doing some code. It's not much, but we will be doing some code. But the semantic kernel will make it easy for us to wrap our database, perform vector search, and even the RAG. And because it has lots of cool features, and we will get to explore today the memory feature. Standard cosine similarity across the database or any other extra efficient worth mentioning. Yes, we are going to get to that when we get to the notebook. So it's cosine similarity. And you get to choose the type of search that you will perform on your database. There are 3 available types, but let's leave that to the database part. So now, some concepts, because some of you may have never heard about all of these things before. So this is a sample from our data. It's a NoSQL data. It's a JSON document. It has an ID, a title, a content. And this data is some data I found on GitHub in a demo repo. And it's basically some Microsoft Azure services. But why am I using it? Because I do not have that much data available, and this data was good for testing because I know Azure and I know its services, and I know if what is I'm getting back is correct or not. And these are my vector embeddings. So what is vector embeddings? For those of you who don't know, it's some numbers that hold the semantic meaning of the words inside them. And these numbers are in vectors, which we get to check the similarity or the distance between each vector. And that's why we have some functions like the one that Phoenix was asking about, which is the cosine similarity. And this function basically takes the 2 vectors and sees how far are they from each other. If they are close to each other, it brings us back the answer as a response to our query. If they are not, it does not. Then, RAG. Also, for those of you who don't know RAG, retrieval augmented generation is intelligently retrieving some data with vector search. Okay, and feeding it to my large language model, which is the ChatGPT model, and making it answer based on this data and only this data using prompt engineering. So that's how RAG works. I apply vector search. As I told you, vector search will calculate the similarity between 2 vectors, gives me back one answer or some answers, and I will take the best one, give it to my chat model, and tell it to respond to the user query from this content, only from this content. And now I have a grounded model that only responds from relevant content. Okay, let's get started. So now we are inside our, by the way, the Cosmos DB for MongoDB core can take up to 10 minutes to get created. It's a big database. And but Codespaces is working now. We are going to go to this one, because I have it open and it has my secrets already stored inside it, because I'm not gonna export my secrets live. But all you need to do is to go to your database, to go to the deployment, to go all of these places and give the name. This is the name of the embedding. This is the name of the deployment. This is the name of the endpoint, the API key from keys and secrets, and the Cosmos connection string. And this is from connection strings at Azure Cosmos DB from MongoDB vCore. And this is the type of the Azure Cosmos DB, because there are lots of Cosmos DBs out there. And we want the MongoDB vCore. And because Semantic Kernel only supports the vCore currently. Also, we need a container name and the database name. These resources, the container name and database name, have not been created yet, but they will be created later on. After we do this, we need to load our environment variables using this command. Then that's what Phoenix was asking about, which is some parameters here that we will get to talk about a little bit. So the first parameter to create our index is a name of course. I can't share the GitHub repo in the comments. I don't know why, but I encourage you all to go to let me see. Can you go to the last link that says bit.ly/rag-sk-cosmos-vcore? This URL has, I don't know how can I, okay. So this URL has steps that I'm doing right now, but it won't have the explanation for the code that we will get to do right now. Thank you. Now it has the repo too. Look for the repo down at fork repo step 2, I guess, or step 3, I can't remember. So now we have this one. What were we saying? So we were saying, yeah. So we are using the text embedding EDA, and this text embedding EDA generates a bunch of numbers. These numbers have a specific dimension, okay? And we need to give these dimensions to our index to know the lengths of our vector embeddings. Thank you, I don't know who shared it, Isaac. And also the number of lists. So this number of lists and is the number of IVF clusters. Oh, by the way, we are not going to specify that we need an IVF type of cluster. There are two types. There are HNSF, which we will get to use today, because the semantic kernel has a function, a built-in function that creates the index with IVF. So we don't have the option to specify the type of index. The only one available is the IVF index. So we will be using IVF index, and it has something called number of clusters of search that gets created. So we are going to specify it in the number of lists. The similarity, there are different types. We will use cosine. You can experiment with L2 and IB, Euclidean distance, and you can read this article to learn more about the different types of similarities. After that, semantic kernel makes it really easy, by the way. Here, this is a function. It's a helper function. It does not do anything rather than adding the data. And let me show you the data. I already showed it to you. So this is the data again. But what we are doing here is that we are reading this file line by line and checking if it exists on the database. And if it doesn't, we save it. And these are some fancy loader that will appear in the comments or in the output of the cell when we run it. So then we initialize the semantic kernel, of course, and we import chat completion and the text embeddings because we are going to use them. And registering or adding a service to the semantic kernel is as easy as that we say kernel.add service. Then we give it the service with the deployment name, the endpoint, the API key, and all of that. And we are going to add our two services, embeddings and chat. And then this is the code that creates the database and container and vector. It is built in the semantic kernel. As I told you, under the hood, it's using by Mongo connector to do that. But what we get is that it creates everything for us. We just say Azure Cosmos DB memory store to create. And there are two types of memories in semantic kernel. The store, which is our database, and the memory, which is the semantic kernel memory, not the database. So differentiate between these two things. In 0.3 seconds, it created the container. The container and everything is working. Now we are going to add it to the semantic kernel memory. So we are adding our data store to the memory. Then we will generate the embeddings. By the way, the semantic kernel will generate the embeddings for us and save it to the memory. Look, it's generating embeddings and saving new data. This is the fancy loader that I told you about. So now it's 107 record that got added. This is happening live. If I run it again and I say it's kidding because item already exists. Then if we go up there, let me show you something here because I want to show you. We are just calling memory.save information. You give it the collection name, the ID, the text. And this text is where our embeddings get generated from. This text maps to the content here field, which is the biggest data I found here. So I took it and I'm generating embeddings based on it. Now we did created our database. We did registered our memory store. We registered our chat and embeddings model. Now what? Now we try vector search. So we just say memory.search. And memory is SK memory or semantic kernel memory. That's it. You give it the collection that you want to search, which is the container containing your database. And you give it the query, which is just question. What is Azure database for managed instances? And please drop your questions in the chat if you want. If you want me to try to ask it, but like make it related to Azure services, please. Now we print this in a fancy formatted way, which we don't care about. All we care about is that it gives us the correct answer and it gives us the similarity or the relevance score, because this is again vector search and it calculates the distance between vectors and gives us back the answer to how the vectors are related. Then we are going to define our prompt. And the prompt is what makes it only respond based on the relevant responses. It grounds our model. So what are we saying to our chat model? We are saying to it, you are a chatbot that can have a conversation about any related topic to the provided context and give explicit answers from the provided context or say, I don't know if it doesn't exist. And I am giving it a variable, which is the DB record, the database record that I returned here from the vector search, and the user query. Then we will define a semantic function, which will get triggered to do our chat. When we define a semantic function, we need to define two more things. The template config, which needs the execution settings. These execution settings is where we define how many number of tokens, the temperature, and because we don't want any creativity in the response, we want it to respond from the data. We are making it 0. The top probability, you can experiment with it, but I used 0.5, you can use anything. And then we define the variables here that will be sent to the semantic kernel, that will be sent to our database, and it will be sent to the chat service to respond from. Now I run this cell, and it says prompt is not defined. I guess I didn't run the cell for the prompt. Yes, please add your questions. So now it did work. And we define function from the prompt. Then let's see, does it work? It does, and it responds with a less and more relevant response, I guess. And now we are going to test everything out. So I'm going to invoke the vector search. We are going to invoke the semantic kernel chat deployment based on the response from the vector search here. So we are going to send this to our chat service to respond from here. And we print it. That's it. Let's see. Now here we can say hello from Jupyter notebooks, and it will respond, hi, how can I assist you with Databricks? So you know why it said Databricks? Because Databricks is related to Jupyter notebooks, and it thought I'm asking about Jupyter notebooks. What is Azure Cosmos DB for MongoDB vCore? And it's a full image there. And then let's say exit, and it's gonna say goodbye. Now all of this can be wrapped. If we don't have questions, let me show you something. So all I did to make a website out of this is what? You will get a copy, I guess. Is what? I took all of this code, I put it inside a file, which is my rag file, surprisingly, and I am calling the functions here from my website. So when someone calls my chat, they say, do you want a vector search? High level steps. Wait. I guess you can find it in the bit.ly link. Okay, I guess I need to install it. Yes, I guess you will be able to access the video. Oh, by the way, what I'm doing right now is let me try the bash script. The front end is a simple page, by the way. So if we go back here, okay, the front end is one page. It has some JavaScript that sends the request, and this is from Pamela Fox Quick Start Chat. It's an Azure sample. It's called Chat Quick Start. I can't remember the name exactly, but it's a very simple JavaScript code and some HTML that you get to try to say, hey, and it responds back, hello, how can I assist you? And you get to choose vector, and if you say hey, it's gonna give you not found, I guess. Oh, A is related. Okay, let me try something more complicated. What is the best rental service in New York? Oh, I guess my vector search is not that good. So if we try rag, if we try rag, it should say, I don't know. Yes, I don't have an answer that is not related to the provided context. So now it understands my question. But if I ask my vector, it's going to return anything related to it. And yeah, that's it. If you have any questions, I don't know if you have questions on that. Okay, so if you don't have a question, yes, we are being charged. This is my handle on social media. You can reach out to me with questions, and you can definitely check the bit.ly link that I shared with you before. Thank you, everyone.